So in the last video, we calculated clearance, which was the amount of a substance urinated per unit time, maybe per minute, divided by the blood concentration of that substance. And we calculated it with some toy numbers that we've made up. But what if you actually wanted to measure the clearance of some substance in some person? How would you do that? Well, you would need to know both the denominator and the numerator. And so how would you get the blood concentration? Well, you would just take a blood sample and measure the concentration. And how would you measure the amount urinated per minute of some substance? Well, the key is to realize that that is equal to the concentration of that substance in the urine times the volume of urine that you produce per minute. Now, this too is actually pretty hard to measure, so what you might do instead is measure the volume of urine that you produce per day and then figure out what that corresponds to in terms of volume of urine per minute. And so practically speaking, what you could do is collect someone's urine for an entire day, put it in a bucket, and then in that bucket measure the concentration of the substance you care about in the urine. And so the way that this is often written out is clearance is equal to the urine concentration times the urine flow rate, and this is written as a V with a little dot over it. The V means volume and the dot means over time, so the change over time. So that's a urine flow rate, divided by the plasma concentration of the substance. Sometimes you might see UX and PX and CLX, meaning the clearance of substance X is equal to the urine concentration of substance X times the urine flow rate divided by the plasma concentration of substance X. So we calculated that if you have a concentration of urea in your plasma of 10 milligrams per deciliter, then the amount that you filter every minute is going to be that times GFR. And if your GFR is 100 milliliters per minute, then that works out to 10 milligrams per minute. So then I have a question for you, which is how much urea are you going to pee out every minute? And on first glance, you might be tempted to say 10 milligrams per minute, because if you look over here at a nephron, you see that whatever is filtered out of the glomerulus has nowhere else to go other than down the tubules of the nephron into a collecting tubule, through the urinary collecting system to the bladder, eventually to be peed out. But actually, your answer would be wrong, because there is somewhere else that this urea can go, and namely, it can be reabsorbed. So as it goes through the nephron, it can get reabsorbed. If we draw that over here, that might be here. And we mentioned this process, reabsorption. What we didn't mention is that there's actually also an opposite process, which is not relevant for urea, but in general it's important to know about. And that opposite process is called secretion. And the idea of secretion is that instead of reabsorbing something into your bloodstream, you can actually take something from your bloodstream and put it directly into the tubules of the kidney through the walls of the tubule rather than by filtering it at the glomerulus. So now in the case of urea, some of it actually is reabsorbed, and the amount in this case might be about 5 milligrams per minute. So about half the amount that you filtered might get reabsorbed into your bloodstream, which leaves the other half to get excreted. So you'll be excreting about 5 milligrams per minute. And now you might have a question, which is, well, urea is a waste and we're trying to get rid of it, so why are we reabsorbing it? And that would be a really good question. And the answer is that the body doesn't necessarily want to reabsorb urea, but it happens anyway, because urea is a small molecule. It can diffuse pretty easily, so you do end up reabsorbing some, even though you probably don't want it. Now, this doesn't happen for all wastes that you excrete. And for example, there's one waste that you excrete called creatinine, and that's actually a breakdown product of muscle creatine. Creatine is a molecule in muscle, and creatinine might have a concentration of maybe 1 milligram per deciliter in your plasma. And so since it's freely filtered here in the capillaries, just like urea, just like sodium, that means the amount that's filtered here at the glomerulus would be about 1 milligram per minute. And creatinine is not reabsorbed. So none of it is reabsorbed. Actually, it is secreted by a tiny amount. So there is a tiny bit of secretion of creatinine into the tubules, but mostly this 1 milligram per minute is what you're going to excrete. So down here, you'll be excreting about 1 milligram per minute, maybe a little more, given that you secreted some, but about 1 milligram per minute. And one thing I want to make clear is that I keep saying that you're peeing out some amount per minute, and you might have a complaint, which is that you don't pee every minute. And that would be true, so I guess a more accurate thing for me to say is that you're putting that amount into the bladder per minute. Because the way it works is you fill your bladder continuously, and then once it's full, you go to the bathroom and empty it.